Hello students, welcome to Vyas Certification Quota. In this series of NCERT discussion, we are talking about NCERT class 11th today, and the chapter that we'll deal with is trigonometric functions, which is chapter 3, and today is the turn of exercise 3.1. So without wasting any further time, we'll continue with the first question here. Let's take a look at this question. What does the question say? Find the radian measures corresponding to the following degree measures. Okay, you're given some angle in degrees and you have to find an equivalent angle in terms of radians. Radians, that is the SI unit of angle. So how do we interconvert between these two things? We'll use something called interconversion formula. Now what are interconversion formula? Let's take a look at that over here. For interconversion, remember that if this is a straight line, right? And if we go about one complete rotation about this line, if we follow one complete rotation about this line, what we have is a circular path, right? A complete circle is equal to how many degrees or is equal to how many radians. That's the important thing. If you are aware of that, then we can apply interconversion very easily. For example, a complete rotation in terms of degrees is 360 degree. Degree is represented in this manner, right? In this fashion. This is 360 degree. What happens in case of radians? In case of radians, this complete rotation is equal to 2 pi. And in case of radians, either we can write RAD over here or we can leave it as it is. 360 degree is equal to 2 pi radians. That's how it is read. Right. Once you are aware of this, we can find the conversion factor very easily. We can find the conversion factor. Yes, 1 degree. If 360 degree is equal to 2 pi, then 1 degree is equal to 2 pi over 360. What is that? Pi over 180 radians. Right? This is what you can have. This will be 1 degree will be equal to pi upon 180 radians. That's what you can observe clearly. Alternatively, you could also have found 1 radian. 1 radian will be equal to 360 over 2 pi degree. That's what you can have. 2 pi divided over here. 1 radian would be equal to 360 upon 2 pi. This is very simple ratio and proportion concept. And what are we doing over here? That if you get in 360 rupees, if you get some number of toffees, then in 1 rupee, how many toffees would you get? That's the simple idea behind this. In 360 rupees, if you get, let's say, some 1000 toffees. So in 1 rupee, you will get 1000 upon 360 toffees. Here, instead of 1000, we have a 2 pi, right? Imagine in that way, right? So once you have imagined in that way, similarly, we have found 1 radian is equal to this. This is a conversion factor. Okay, and what are we trying to solve over here? We are trying to solve degrees in terms of radians, right? We are trying to write degrees in terms of radians. Let's begin with the first part over here. The first part has 25 degrees. Now 25 degree, 1 degree is equal to what? This is basically 25 times 1 degree, yeah. So this is 25 times, imagine this as this is 25 times 1 degree, right? This is 25 times 1 degree. And what is this equal to? 25 is okay. 1 degree is equal to something. We found that 1 degree is equal to pi over 180, and this is in terms of radian, right? So this is 25 times pi upon 180 radians. This is what you get, right? And remember one more thing. For if you have any kind of confusion related to whether we'll be multiplying with pi by 180 or whether we'll be multiplying with 180 upon pi, remember that the measure in radians, mind you, the measure in radians, the value in radians would be much smaller as compared to the value in degrees, numerical value. Like 360 degree was equal to 2 pi. Now 360 degree is huge number as compared to 2 pi, right? 180 degree is equal to pi radians. Pi is approximately 3.14. 180 is a huge number. So in terms of degrees, you get a numerical value which is much bigger. In case of degrees, you get a numerical value which is much bigger. So this numerical value has to be bigger as compared to the value in terms of radians. This is what you'll be doing, right? Pi upon 180. If you multiply this factor over here, you'll get the value in terms of radians. Okay? So let's simplify this further. 25, 180. Will this get cancelled? Yeah. The factor of 5 will get cancelled, and you can say this is 5 pi over, what you get over here is 36 radians. This is what you get, right? Or you can simply write it as 5 pi over 36. There's no need to write RAD over here. This 25 degree is equal to 5 pi upon 36 radians, right? This is what you find. This is first part for us, which is very simple. Similarly, we can find the remaining parts as well. Let's try to do that. Let's try to solve for the second part. What does the second part say? We have minus 47 degree 30 minutes. Now that 30 minutes has to be converted into degree first, right? So what you have is minus 47 degree 30 minutes. Now 30 minutes is basically half a degree. 1 degree, since 1 degree has 60 minutes, 30 minutes would be half degree. This is minus 47.5 degree. This is what I have, right? Minus 47.5 degree, right? That's pretty simple, yes. Since you are aware of the degree angle, now you can find the angle in radians. Simply multiply by pi by 180 and you get the angle in terms of radians. Minus 47.5 times pi upon 180. What else? Is there anything else? Yes, you can simplify that factor. This factor. This is 47.5 can be written as 47, 90, for 95. You can write it as minus 95 over 2 times pi upon 180. I'm writing 47.5 as 95 upon 2 so that I can cancel the factors. Let's do it. What you have over here is 5. A factor of 5 gets cancelled. This is 19. This is 36. So what you get is minus 19 pi over 72. Minus 47 degree 30 minutes is equal to minus 19 pi upon 72 radians. And that is my answer over here. That's okay? Yes, that's pretty simple. What next? Let's talk about the third part after this. For solving the third part, let's get rid of this thing over here. And what do we have remaining is, let's take a look at this third part. 240 degree. Now what is that equal to? Let's take a look at this 240 degree. 240 degree will be equal to 240 times pi over 180 in terms of radians. This is in terms of radians, right? 240 times pi upon 180 radians. Now what is this equal to? This is basically 60 times 3 and 60 times 4. This is 4 pi by 3 radians. 240 degree is simply 4 pi by 3 radians, right? That's clear? Yes, that's pretty simple. What next? Fourth part. In the fourth part, you are asked to find 520 degrees. 520 degree is equal to what? 520 times pi by 180 radians, right? This is what you'll get. And what is this further equal to? We can cancel a factor of, can we cancel anything? Yes, a factor of 2 at max, that's all. This is 26 pi upon 9 radians. This is 26 pi upon 9 radians. And with reference to this question, that is enough for us. But then, since we are talking about degree and radian interconversion, we should study one more thing. We should take a look at one more thing, that is some standard angles whose degree and radian, both values you should be aware of both versions, right? Let us talk about some standard angles. For example, 0 degree, 30 degree, 60 degree, 45 degree first, and you have 45 degree, 60 degree, 90 degree. Okay, these are very standard, right? After 90 degree, you can move on to next 120 degree, 135 degree, 150 degree, 180 degree. What else? After 180 degree, you can move on to 210 degree, 225 degree, 240 degree. We have just found 240 degree, right? That's a standard angle, yes. Many a times you would encounter these angles, right? So you should be aware of the degree measures and the radian measures simultaneously. Next is 270 degree, 300 degree, 315 degree, 330 degree, and 360 degree, right? These are some measures. So what is 0 degree is equal to? 0 degree in terms of radian is simply 0. 30 degree is simply pi by 12. This is pi by 6, not pi by 12. 0 is 0, 30 degree is pi by 6, this is pi by 4, this is pi by 3, this is pi by 2, okay, right? What else? In case of this range over here, this is pi. You remember 180 degree, this is pi, this is 2 pi. You remember these angles, right? Pi and 2 pi are pretty simple, 180 degree and 360 degree, but the others can also be found. Now 45 degree times 3 is 135 degree, so this is actually 3 pi by 4. This is actually 3 pi by 4. How do we find 120 degree? 60 times 2 is this. So this is 2 pi by 3 actually. What about 150 degree? 150 degree can be found by multiplying this with 5. 30 degree times 5 is 150 degree. This is 5 pi by 6. Right? This is 5 pi by 6. Or you can also do one more thing. 180 degree minus 30 degree. 180 degree minus pi by 6, that is pi minus pi by 6. Pi minus pi by 6 is 5 pi by 6. Similarly, 210 degree is pi plus pi by 6, which is 7 pi by 6. Right? This is under the standard angle. Pi plus pi by 6, pi minus pi by 6. With the help of these. With the help of these. What about 225 degree? Can you imagine now? 225 degree would be based on this. 45 degree. 45 degree times what? 45 degree times 5 is 225 degree. This is 5 pi by 4. What about 240 degree? 240 degree is nothing but 120 times 2, which is 4 pi by 3. You may observe that, right? What next? 270 degree. 270 degree is simple. 270 degree is actually, if this is 90, 90 is pi by 2, this is 2 pi by 2, this is 3 pi by 2. Then 300 degree. 300 degree again, this is pi 30 degree and 300 degree would be 10 times this. 10 times pi by 6 would be 5 pi by 3. There's another way of reaching 300 degree. What is that? 360 minus 60. That is 2 pi minus pi by 3. 2 pi minus pi by 3 is 5 pi by 3. What about 315 degree? Yes, 315 degrees, 45, 135, 225 and 315 are similar. This is pi by 4, this is 3 pi by 4, this is 5 pi by 4, this is 7 pi by 4 over here. What about 330 degree? This is 2 pi minus pi by 6. 2 pi minus pi by 6 is 11 pi by 6. This is what you have. Right? This is 11 pi by 6. I hope these are clear, right? A few more angles remain, yes. What are a few more angles? Let me write a few more angles in terms of degrees and radians. 15 degree, 75 degree. These are some angles. 22.5 degree, which is also 22.5 degree. Now, what are these measures in terms of radians? 15 degree is equal to basically half of this. This is pi by 12 for us. What about this? This is 5 pi by 12 for us. What about 22.5 degree? This is half of pi by 4, which is pi by 8 for us, right? So remember these values. Yes, these values are important and you should remember these values very nicely. So can you observe that 180 degree is pi, we have pi by 2, pi by 3, pi by 4, and do we have pi by 5 as well? No, we haven't written pi by 5. Let me write pi by 5 as well. 36 degree. What is that? That's it. 36 degree is pi by 5. So is 36 degree also in standard angle? Yes. When you're preparing for competitive exams, you would also be required to remember the values of sine 36 degree, cos 36 degree, right? Sine 18 degree, cos 18 degree, and we actually tend to derive all of those values. How do we get those values and all, right? So 36 degree again standard. Then you have pi by 6 is you are aware of pi by 6 now. Pi by 7 now, 180 degree is not divisible by 7, but pi by 8 is something which you have dealt with. Pi by 9, you can deal with pi by 9 as well. Pi by 9 would be pi by 3 into 1 by 3, which is 20 degree actually. Then pi by 10 is something which you can deal with. Pi by 10 is 18 degree. Once again, a standard angle pi by 10. Okay, so these are some interconversions between radians and degrees. Okay, you have converted some angles and degrees into radians. After this, we'll take a look at the next question.